An instance of class node is a node of a singly linked list. Field val contains the value of the node, and field next contains either a pointer to the next node or null if there are no more nodes. Class node has methods, but we don't need to know about them for this video. We show a linked list pointed to by h. It represents the list containing 8, 2, 6, and 3. We develop a recursive function to reverse linked list h. Here's its specification. Note that only the next fields should be changed. As an example, the assignment r becomes rev of h should produce this change in the list, with r pointing at the result. The first step in writing this recursive function is to identify the base cases and write code to take care of them. It is in your best interest to pause the video and perform this step yourself. Please do that. When you are finished, proceed with the video and see how we perform this step. The two simplest cases are a list of length 0, indicated by h containing null, and a list of length 1, indicated by h.next containing null. In both of these cases, the reverse of linked list h is itself, so there is no work to be done. The two base cases are easily implemented. We emphatically do not consider a list of length 2 as a base case because processing it would cause us to reverse the linked list, and we do not want extra work in base cases. We now deal with the recursive case. After the code for the base case, we place a comment that shows an example of linked list h. We handle the recursive case in 3 steps. Step 1. Write a recursive call on function rev. Its argument must be a shorter linked list than parameter h so that progress towards termination is made. Step 2. Since rev is a function, assign the value of the call to a new local variable, say r. Step 3. This next step is important. Look at the specification of rev. Based on it, write a comment after the assignment statement showing the linked list and variables h and r after the assignment statement. You see how careful we were in drawing the comment? Be just as careful and as precise as we were. Pause the video and carry out the 3 steps shown above yourself, carefully. Proceed with the video after you are done to see how we do these 3 steps. According to the specification, the recursive call r of h.next reverses all but the first node of the list, and we assign its value to a new local variable r. Here is what the variables and linked list are after the call. Variable r points at the first node of the reversed list, which points at the second node of the reversed list, which points at the third node, which has null in its next field. Variable h still points at the first node of the original list, and the first node still points at the second node of the original list. To complete the reversal of linked list h, these 2 red next fields have to be changed. Let's copy the comment. First, change the next field of the second node to point to the first node h. Second, since node h is now the last node of the reversed list, change its next field to null. Now the whole list has been reversed and r can be returned. What helped us develop this function? First, we wrote an example of a linked list as a precondition of the assignment of the recursive call to variable r. Second, we wrote a corresponding postcondition of that assignment statement that also serves as a precondition to the following lines. The postcondition was based on the specification of the function. Third, we wrote a postcondition of the 2 statements that completed reversing the list. This made the development easy.